In the video 1.2 graphing lines, we talked a little bit about a linear system. One thing that we can actually do is solve a linear system by graphing both sets of lines. So in order to have a linear system, you need a pair of linear equations. And when you are solving a linear system, it means to find the point that both equations have in common or the point where they intersect. So in order to solve manually, you would graph two lines using an appropriate method, and then you can check your solution using the left side, right side method. So here, my first equation here, y equals 6 minus 2x, I would graph that using the slope y-intercept method. I can see that my slope is minus 2 from the coefficient in front of the x, and my y-intercept is 6. So here, I would plot my y-intercept here, and then I'm going to go down 2, so down 2 over 1 to get to my next point, and then I'm going to use a ruler Oh, that's the best line yet. Use a ruler to draw a line through those 2 points, and then I'm going to label my line here. My second one is in standard form, so I'm going to find my x-intercept and my y-intercept and graph those. So I'm going to first sub in y equals 0. That's going to give me 3x equals 10. Disappointing that it's not a great number. And then I'm going to find my y-intercept by setting x equal to 0. So I've got 3 times 0 plus 2 times y minus 10 equals 0. And that's going to give me 2y equals 10, fit it in the bottom here, and then I get y equals 5. So that's much better. So let's plot those 2 points. So I've got 10 over 3 and 0, and then I've got 0 and 5. So I'll do my y-intercept first, because that was a little bit easier to plot. And then I'm going to do my x-intercept. So 10/3, so that's like 3 and 1/3. So that is probably right about there. And then I'm going to do my best to connect those 2 points using my line there. Now it looks like to me the black line and the pink line, so I'll label this one 3x plus 2y minus 10 equals 0. It looks to me like they intersect at the point 2, 2. Now I'm going to double check that algebraically since I am graphing by hand. So here I've got my left side and my right side for equation 1. So I've got y on my left side, 6 minus 2x on my right side. I'm going to put in 2, and then 6 minus 2 times 2. That also gives me 2. Great, things are looking up. Let's check our second equation. Left side, right side. So my left side is 3x plus 2y minus 10, and that should equal 0 if 2, 2 is on the line. So I've got 3 times 2 plus 2 times 2 minus 10. And here I would have 6 plus 4 minus 10, which indeed equals 0. So therefore, my point of intersection is 2, 2. The other way that you can solve a system graphically is by using a graphing calculator. Now, we're not going to use the graphing calculator a lot. If you have one, that's awesome. If you don't, there are what's called emulators. I have an Android phone and I use an app called Wabbit Emu. It's free. I believe for iPhone there's one called Calculate 84, and I'm looking into a solution for the Chromebooks. But those are two apps that you can use if you want to test. And I will link a video in our classroom with a screenshot of doing it on the graphing calculator. These two steps just reset the calculator to clear any memory before. In your y equals window, you want to enter your two equations. So our first one is 8x minus 9y minus 41. But on the graphing calculator, they all have to be in y equals mx plus b form. So let's rearrange these ones first. Do that underneath. So for equation 1, I would have minus 9y equals minus 8x plus 41. Then I would divide everything by minus 9. So I'd have 8 over 9x minus 41 over 9. My second equation, I would have 3y equals minus 4x plus 3. Then I would divide everything by 3. So I'd have minus 4 over 3x plus 1. And then we can now plot those in the graphing calculator. So my first one is 8 over 9x minus 41 over 9. And then my second equation is minus 4 over 3x plus 1. Then, once you've entered those two equations, you can press graph on the graphing calculator. And the two graphs should show up on your screen. Then your next step would be to find the point of intersection. So second, trace. Option 5 is what you are looking for. You then need to identify the two curves that you're using and then make a guess at where the point of intersection is. And then the calculator will spit one out for you. And you should get 2.5 minus 2.33. I'll link a video probably in Brightspace so that you can see the screenshot of me using the graphing calculator. So you can see what pops up after each step. Okay, but I'll show you the solution to the second one too. So the first thing is that you want to rearrange into y equals mx plus b. So I'll start off the same way here. Equation 1, equation 2. 2x plus 6. And then the second equation, we would end up with minus 5x plus 2. And then we'd end up with 5x minus 2. And then I'm going to follow the same steps on my graphing calculator. So I'll go back to my y equals screen, clear the equations that I had from the previous question, and re-enter these ones. So 2x plus 6 and 5x minus 2. I'm going to graph those two equations. And on this one, for me, I have to change my window settings to be able to see where the point of intersection is. So I modified the maximum value on my y so that I could see 50. So now I see the point of intersection. I'm going to identify my curves. make a guess by moving the cursor, and it spits out a point of intersection. You can see by the decimal answers that these two would have been very challenging to graph by hand. Using technology and graphing the lines is an excellent way to solve a system of equations.